All right. Everybody at 25? Quadrilaterals. Follow along, guys. So on your study sheet, I want you to have triangles, under geometry triangles, then quadrilaterals, and just make sure you know that it's a closed four-sided shape. The sum of the interior angles is always 360. And each time you add a property, you have a different quadrilateral. Okay? And notice the sides. You see the arrows on the side always, sometimes. Okay? So, for the most part, if this one is the quadrilaterals, just has all four sides, and then on the left side we have a parallelogram, rectangle, rhombus, square. In the middle we've got the only shape that has the name of kite, looks like that. Then trapezoids, we branch into two different trapezoids. Okay. So let's go to page 26 and just write down those properties. Page 26, okay? We're going to write down, I'm going to try to add some color to it. Sure. You ready? A parallelogram. So one thing we know about a parallelogram is it's got two pairs of parallel sides. And parallel, okay, the symbol for parallel is just the two lines in a slight slant, okay? It's got two pairs of congruent sides. And the symbol for congruent, I kind of gave you a heads up yesterday, is the equal sign with a third wave, okay? And then it's got diagonals bisect, cut in half. One long and one short diagonal. And of course, they always add up to 360, okay? Interior angles always add up to 360. I don't have to say that. That's true for all of them. And so, if you want some color to this, I have at least 4 different colors here. If not more, I might have to resort to another one. But if you want to have this in terms of, for your study sheet, to make it very concise, okay? This one right here, this one, the two parallel, you just have to do this. If I saw that, I would know there's 2 pairs of parallel sides. Okay? 2 pairs of congruent sides. You do this. Okay? Diagonals bisect. So this one, I'm going to use a pencil to draw them. Okay? So the diagonals, there's a long one and a short one. I'm going to use red pen for the longer one. And then a blue pen for the shorter one. So this is my short diagonal right here. And I haven't used pink yet. So the bisecting part, this part, where they cut each other in half, you just take this and just go technically there's something wrong with this. So I will, because I used 1 mark, 2 marks. So I'm going to go 3 marks here and 4 marks there. At that corner. Noah, you were saying this part you don't get?
Yeah.
So if I had put 1 and 1 here, and then you see that this is 1 and that's 1 as well, then you're saying that all of these are the same. You know what I mean? So to distinguish between these two and these two, I'm also now using 3 and 3, saying these two sections are the same. 4 and 4, you're saying these two sections are the same. So if I used 1 mark everywhere, then
Colors are for the different sections.
from here to here, this stretch is the same as from here to here. Okay, rectangle. What's different? The only thing that you would have to change from here to here is all angles are 90 degrees or measure 90 degrees. Diagonals are what? Are they different or are they the same? They are congruent. So if you wanted to make a change, how do you make a parallelogram into a rectangle? You ensure that there's 90s in the corners. And you make sure that the diagonals are the same. So blue and blue, right? I'm going to use it the same color because I'm telling you with that they measure the same. So I'll make a note here. Different than the parallelogram. So these make it unique to a rectangle. So everything is still true. These 3 are still true, except for instead of a long and a short one, you now have the diagonals being the same, and all angles are 90. Okay, so that changes a parallelogram to a rectangle. Keep going. The other shapes. I'll say this. Everything in parallelogram plus what makes it special? What makes a rhombus a rhombus? It's a slanted square. So what do we know about all the sides? All sides are equal. So this makes the rhombus different. So we're going to go markings like that. A square everything in parallelogram plus all angles are equal to 90 plus all sides are congruent. So the plus the 90, I'm just going to do that. And all sides being the same. And let's go up here. Can we go to the rectangle above the rectangle? Above, I meant to say everything in parallelogram. That is short for parallelogram, by the way. That's right next to parallelogram. So everything in parallelogram plus whatever is written down here. Okay. So listen to this part. This is the important part here. Any of these three here, okay, can always be a parallelogram. Like they can always be labeled as a parallelogram. But you cannot say that all parallelograms are rhombuses, or all parallelograms are squares, or all parallelograms are rectangles. You can't say that. But you can say that all three of these are definitely under the parallelogram category. So the parallelogram is kind of like our foundation, and then we branch off to the rhombus, or we could branch off to rectangles or to squares. Okay, so every one of these three has something that makes them unique. Okay, and so that's where the plus comes from. All right, let's go to 27. These are very easy to come up with properties. They're very straightforward. A right trapezoid, it's got two right angles. And it's got one pair of parallel sides. That's it. There's not much to be said about a right trapezoid. And for the angles, I'm just going to put a little marker there, and obviously it's these ones. And the parallel sides, I'll just use orange. So we just indicate it by having arrowheads like that. So those two lines will never meet. That's it. Isosceles trapezoid, where's that coming from? We only know isosceles triangles, correct? Think of an isosceles trapezoid as a triangle, an isosceles triangle that has been cut in half, or the top part has been chopped off. Okay? So one pair of parallel sides two pairs, hold on, yeah, I'm good, two pairs of congruent angles and diagonals are, you know what this means, right? By now you should know that that means they're the same. So I'm going to go with diagonals first. So I'm just letting you know that this and that is the same in length. Make a note though, they don't bisect. They don't bisect. And here's your angles. I'm not going to use a color for this, but we know that this angle at the base here is going to be the same as this one at the base over there. And the top ones here are also going to be the same. And the parallel sides, I'm going to use the same color. Orange. What's the only thing that both trapezoids have in common? It's an orange. They both have one pair of parallel sides. That's about it. Okay. And they have 4 sides, of course, but other than that. These are your trapezoids. I forgot something about the rhombus, which makes it very special. I don't want to forget, so I'm going to go back to it. This makes the rhombus very special, okay? Diagonals meet at 90 degrees. Do you remember this word? Perpendicular. The symbol for things meeting at 90 is just an upside down T. Okay? So that means that they will meet at 90 degrees. So I really want to add that to the diagram. So I'm going to go back to my red and blue pen just to show you that there's one that's longer than the other. And make sure you put the 90 in there. What color should I use? I'm going to go with this color. So if you see that all sides are the same and that the diagonals are meeting at a 90, you know for sure that it's a rhombus. 27, back to 27. A kite. Should I do this? I'm just going to do this. Not a diamond. So then when you read through the notes, you'll be like, oh yeah, don't mention that it's a diamond. Okay. It's got 2 pairs of equal sides. You know what? Honestly, if you put equals on your study sheet, I don't care. It's just congruent. Diagonals. Meet at 90 degrees. Short diagonal bisects. Not both, right? Just the short one. And one pair of congruent angles. I think that summarizes it. So I'm going to use, for diagonals meet at a 90, I'm just going to have that here. Two pairs of sides that measure the same. So you go, these two are the same, and these two are the same. One pair of congruent angles. It's this one and this one. Green isn't really a good color to use, eh? It's hard to see, but it is what it is. And short diagonal bisect. So I'm gonna use yellow here. Whatever color you have, right? Like you just want to make sure you understand that this short one here is cut in half, not the long one, okay? So think of it this way. A kite has 4 right triangles in it. You can think of it that way. Or think of 2 isosceles triangles stacked. This is an isosceles, and this is an isosceles triangle. They're stacked. So yes, sine law, cosine law can be used if needed, okay? That's it for the properties. Yay, right? Now, I'm going to give you a little bit of class time to put this onto your study sheet. Like somehow find a way to convert this study sheet material right now. And then I'll ask you to sketch some of these, okay? Why are you laughing? It is possible. It's been done before. You just have to like have the willpower and start somewhere. Okay? Right now, if your study sheet runs out of room, you're gonna probably have to make a new one anyways. Okay? So you can just have to make it short and sweet. You can't just do the whole thing. Okay? More later on. That's pretty awesome. At the very least, you should have the names and all shapes. So watch this. I'm going to have a parallelogram. I won't make it too small because then you can't see it, right? But and this is what I'm going to do. I'm going to tell myself that these two are the same, so are these two. Okay? I will tell myself that the top two are parallel, the sides are also parallel. Okay? I will tell myself that the diagonals, you know what, I'm not going to write that in, that's going to be super messy. I'm just going to say this. Diagonals bisect. And that's it. Maybe I will say one long and one short. I'm just going to give myself something here to go off of if it ever comes up. Okay. Then from there you're going to go rectangle. You should at very least have this, the fact that these are parallel. And I'm going to introduce a 90. So I'm actually going to, if this is my study sheet, I would do a 90 there. So that makes this one stand out. Diagonals bisect. Diagonals are the same. There you have enough. In my opinion, you have enough there. I can zoom in if you want, but then you won't have the perspective as to how much space it actually takes up. Next, you have your rhombus, right? How about we do square? square, and rhombus here. There's something about both that we know for sure is the same. So it's 1, 1, 1, 1, right? They all have the same length. We still have the parallelogram features where there's two pairs of parallel sides. This one has all 90s. This one, you know what? That is true for both. For both of these folks, diagonals are perpendicular. And I would like you to have a bit of an umbrella here, because the parallelogram is the one that kind of can be used to create these other shapes. And then next to that is a study sheet entry, right? You've got your kite, and the kite, it looks like this. I think this one you can get away with just marking. So this one is the same as that. This one is the same as that. This angle is the same as that angle. And I'll make another kite right next to it where I will just focus on the diagonals. So that diagonal and this diagonal, right? What happens when they meet? They meet at 90. And the short one is cut in half. So just with those two diagrams, you're actually covering all the properties that you need to know. Okay. Then you've got your, maybe we can squeeze that in here. So I'm going to just do that. These will be your trapezoids. You've got the right trapezoid. And you've got the, some classrooms have trapezoid tables, right? What do we know about the right? We know that there's 90s and 90s, and that there's one pair of parallel sides. Obviously, this one is not the same as the one I just gave you, right? It's not as detailed. But if I had to choose between nothing and something, this one at least could probably get you by. Isosceles, this one is the same as that one. The bottom base angles measure the same. So if you know one side, you know the other one. And the top angles are also the same. I don't know if you need to tell yourself. I'm just going to do one more here. And just say that this is the same as that. That the diagonals are the same. That for me would be code. And then again, you'll make your own study sheet that is better probably than mine. I'm just giving you a start here. This is good. If you have this at least, you memorize some of these things, or you just remember some of the things we talked about, you are going to be fine. There's one more thing I would like you to add though. Of course, right? It's never enough. That the fact that two consecutive angles, they always are going to add up to 180. And I think if we just do that with a parallelogram, just once here, the fact that they add up to 180 degrees. And what's the name for all of these? Quadrilaterals. quadrilaterals. Okay. You have one for triangles, I'm hoping, where you have the classification, right? You've got by angle, acute, right, obtuse, by side length, scalene, isosceles, equilateral. And what do angles always measure in an equilateral triangle? They always measure 60. Please don't forget that. Okay? They always measure 60. So imagine equilateral, a bridge, or like imagine a roof that is an equilateral triangle. Can you change the slope or the pitch of that roof? Can you make it steeper if it has to be equilateral? The answer is no. If it's 60 everywhere, you cannot change if the roof is supposed to be slanted more or not. It's fixed, right? So equilateral triangles are fixed. You cannot change that. Okay, let's go to 28. Okay, just a couple here. I'm going to get you started with this one. 28. Yeah. Go to 28 real quick. This has happened numerous times on the exam where they ask you to sketch one. Okay? Sketch the following, clearly identifying two properties. So you have to somehow, either within words or with markings, tell me two properties about the shape. Make 3 versions of each examples just to get used to it. Kite. You look at your study sheet. I hope that you know what a kite looks like just by looking at your study sheet. One property is that these two angles are the same. You get 1 out of 2 marks already. Give me another property. Look at your study sheet. Let's talk diagonals. What do we know about diagonals? They meet at a, yeah, so you just go like this and put the 90 in there. Check. Two properties done. Or do another kite. Let's just talk about the sides. We know that this one is the same as that one. And we also know that this one is the same as that one. What else do you want to talk about? Let's talk about these angles again. This one and this one. Sure. So imagine this is another student. This student would also get 2 out of 2. Okay. Or I want you to have various ways of answering just in case they say you cannot use this, right? What else do we know? We know that, are any of the sides parallel, by the way, on a kite? The answer is no. All of them meet if you were to extend them, okay? So there's no such thing as a parallel side on this one. So how about we talk about this, the fact that the short diagonal, it's cut in half. And that they meet at a 90. Check. Okay? So that's what I mean. Can you try, even if you just do 2 for each, I'm fine. So do BC, that's all page 28. BC and try the other page as well. Okay? Just do that quick before I move on, because I do want you. So you may use sentences if you wanted to, right? A right trapezoid, you know the general shape, but that's not good enough. So you can talk about, if you talk about right angles, talk about all the angles that are 90, and then talk about the fact that those are parallel. There's not much else to do with right trapezoid, so we're going to leave it at that. Parallelogram. So, sorry, I will just say this. If you wanted to say 2 right angles and 1 pair of parallel sides, that would also suffice, okay? Parallelogram. You should all know what it looks like in general. And if I want to talk about parallel sides, you have to talk about all the sides that are parallel. That's good. And then we also know that lengthwise, this one is the same as that one, and this side measures the same as that one. Okay? So that's one way. Another way could be the fact that when you have your diagonals, that they cut each other in half. So you get two stretches that are the same this way, and two stretches that are the same this way. And by that I mean, if you were to go from the corners to the middle, this would be the same as that one, and so is this one. If you want another one, please don't do the 90 in the middle. That would be a rhombus, right? So we could talk about the fact that this angle is the same as that one, and this one measures the same as that one. That's also an option. And that these two sides measure the same, these two sides measure the same. Done. Okay? So many options there. I will post the key to this. So if you did 29, okay, you can do that. All right. Let's keep going. I'm going to ask you to try 30. Okay? I want you to try A, B, C. You don't have to worry about the area. And then I want you to skip, go straight to, 31, 32. Listen carefully to this part. If you need to find areas or anything like that, you may take the challenge if you want, but you omit them for now. You're not going to need to know how to do that. I teach it when there's time. First semester, I have an extra 5 days. I don't have that with you guys, so I'm kind of just going straight to the point here. So pages 30 to 32, find the missing sides. Also classify it, meaning you have to give it a name. Do that for now. Once you're done those, there's more. I want you to skip a whole bunch of pages. You go to page 40. You go to page 40, you try that one. Then I want you to skip and go to page 47. Go ahead. 40 to 48. Make sure you write these numbers down. These are the pages I want you to complete, okay? And I will